All right, let's get started. Thanks everyone for joining. My name is Andy Roth, and I'm going to be talking about all the new stuff in visionOS. So all this stuff was announced last week at WWDC, and I think that I watched every visionOS video, so I'm going to capture everything. I'm sure there's stuff I'll miss, but hopefully I've got everything. So just a little bit about me. So I'm a freelance visionOS engineer. Most recently, I've been working with Adam Lissagore and the team at Sandwich. We've released a couple visionOS apps. The first is television, and it lets you watch YouTube content and some of your own media on a variety of different TVs that you can then place anywhere within the real world. Everything from futuristic flat-screen TVs to some old vintage CRTs. And then Theater is another app that we built most recently. That's similar. It lets you watch the same content, but in a fully immersive movie theater. And last week, we actually live streamed John Gruber's talk show at WWDC in spatial video to the Theater app, which is really fun. I also have some experience with VR development in Unity and Unreal. But with these projects, having 15 plus years of iOS development experience, I wanted to go fully native and try out RealityKit and see how that compared to the other platforms. All right, so jumping into the agenda. So first I'm going to start with some of the user-facing features, things that are available in the visionOS beta right now, or things that are coming later this summer. And then I'm going to jump into what I think are the really fun pieces, the developer APIs, starting with new additions to volumes and immersive spaces, RealityKit 4, and Reality Composer Pro 2. Some of the new enterprise APIs that are available, and even more. All right, so jumping into some of the cool user-facing features that you can try out right now. The first is this customizable home screen. So finally, we can rearrange apps on the home screen, and you can actually pull out some of the compatible apps out of their little lonely folder. So those live alongside all your other visionOS apps. And one of the big ones is new gestures. So now, instead of having to push the digital crown every time you want to see the home screen, you can just put your palm out, and you look at your palm, and then you can tap to view the home screen. Or you can flip your hand around to see the time, and then you tap to show the control center. Or you can pinch and hold to control the volume. And so this makes it much easier to get to Control Center. You don't have to do the awkward look up at the sky gesture that was in visionOS 1. And then there are also some big improvements to the Mac Virtual Display. So now there are more resolutions available. You can go wide and even ultra-wide. So this will be great for doing any kind of work, especially if you're developing for visionOS. They've added mouse support, so now you can connect third-party mice just for more control options. And keyboard breakthrough. So if you've ever been working, especially in the Mac Virtual Display, where you're using your keyboard and you're in a fully immersive space, you can see your hands, but your keyboard just disappears, and so it makes it really difficult to type. So in visionOS 2, they've added keyboard breakthrough, so your keyboard is actually visible through that immersive space. And an AirPlay receiver. So now you can AirPlay content from a nearby Mac or iPhone into the Vision Pro itself. So you could watch a movie from one of these other devices or screen share into the Vision Pro. In terms of media, so there's now a spatial photo conversion. So this lets you, in the Photos app, take any of your old 2D photos from your library and actually convert them into the new spatial photo format. And I was using this recently, just going back and looking at a bunch of old pictures of my son throughout the years, and it was really fun to see these photos take on a whole new life in 3D spatial photos. They also added full SharePlay support to the Photos app. So instead of just being able to FaceTime and screen share with the 2D photo window, now you get full spatial personas, and you can share these spatial photos as well. Final Cut Pro spatial video editing. So there's an update coming later this year to let you edit spatial videos in Final Cut Pro. Right now, there is no video editing software that can really work with spatial photos very easily. So this will be really cool. Apple Immersive Video. So this is a new video format that Apple announced. It's 180-degree video, 8K per eye, super high resolution, and they're really touting this to create these really immersive videos. And along with that, Blackmagic is announcing a professional-grade video camera that supports this new immersive video format. And they've also updated their DaVinci Resolve software to support Apple Immersive Video as well. And then cinema mode. So this one is really cool. It lets any video player in Safari break out of the Safari window, and you can play it full screen in any of Apple's immersive environments. So you can watch YouTube, Hulu, Amazon Prime content, and just pop it out of Safari and into one of these environments. And Apple also just released a new Bora Bora environment that you can do this. So you can watch your movies from a beach in the South Pacific. Some more user-facing enhancements are for guest users. So I don't know if you've ever had a guest user try on your Vision Pro. They have to go through this calibration step up front. It takes a couple minutes. But then if they accidentally take the Vision Pro off and want to try it again, they have to go through the calibration all over again. And so now with guest user enhancements, their calibration data will be remembered for up to 30 days, so they can continue using it more than just that first time. For persona enhancements, so they've improved some of the skin tones and vibrant clothing colors of the personas. They promise better hand movements for these spatial personas. And with the mindfulness breathing detection, so in the mindfulness app, it will now detect your breathing and sync all of the environment animations to your breathing itself. And with train support for travel mode, similar to airplane mode in visionOS 1, so now you can turn on travel mode on a train and all the tracking still works within a moving vehicle. Live captions. So with live captions, you can turn this on as an accessibility feature, and it actually shows live text representation of what people are saying around you. And so right now this is an accessibility option, but you could see how cool this would be if it eventually supports live translations as well. You can just walk around and see those live translations right in front of you. All right, so now getting into some of the developer APIs, starting with volumes, volumetric windows. So the first new thing about volumetric windows is they have these base plates. And a base plate is a visual representation of the bottom of the volume. So you get a good idea of how large the volume is. Just when you look at one of the corners, it gives you a little reflective shine. And similar to that is volumes are now resizable. So in visionOS 1, they had to be statically sized at build time, and then they could not be configured after that. So you had one set size for your volume. But now with visionOS 2, you can allow users to resize them manually, just like plain windows, or volumes can resize themselves based on the content within that volume. With ornaments, so with visionOS 1, volumes could add toolbars to the bottom, like this little, you can see the blue ornament in that screenshot. But with visionOS 2, now they're fully supporting ornaments, so you can attach these to any side of a volume, the left, the right, top and bottom, and you can even specify the back or the front of that volume. And it's also really cool that these ornaments will change their transforms based on where you are relative to the volume. So if you walk to the side of the volume, the ornament will actually change its orientation so that you can see it. And we can get this programmatically. So you can adjust some of the content within your volume based on where the user is in relation to it, which is really nice because in volumetric windows like this, we can't use ARKit, and so we can't actually get the location of the user's camera like we can in a fully immersive scene. With world alignment, so now by default, volumes will tilt when they're dragged around. So if you have a volume and you tilt it up above you, it will actually rotate to face down towards you. And this is completely optional, so if you want, you can still maintain gravity-aligned world alignment for cases where you want your volume to remain flat. And dynamic scale. So with regular windows in visionOS, as you move them away from you, they actually scale up to maintain their size. But in visionOS 1, volumes, as you drag them away, they just get really tiny. And so now there's dynamic scale support. So if you want, you can choose to have your volumes also scale up as they're dragged away to maintain their size. So with immersive spaces and ARKit, the first, we have some good progressive immersion improvements. So progressive immersion is where you have an immersive scene, but you can use the digital crown to dial in and out the level of immersion. With visionOS 2, they've added the ability to provide minimum and maximum immersion amounts. And so you can really get some fine-grained control over the immersion experience for your app. And you can also respond to changes in the level of immersion. So in Apple's example, this botanist app, when you go fully immersive, the robot actually walks towards you, and then as you dial down the immersion to just a small point, the robot walks away from you. With surrounding effects, you can tint the pass-through video or dim the pass-through video around you just to focus on some content in your scene. In Apple's example here, as the robot walks over to the different plants, it tints the pass-through to the color of that plant. And now getting into some of the ARKit APIs. So room tracking is a new one. This one actually lets you detect when the user moves from room to room. And so you can customize your immersive experience based on the geometry of the room that the person is currently in. With my television app, I was thinking this would be a good idea. So you're in one room and you can place a TV on a table, but as you leave and you go to a different room, I can hide that original TV so you don't see it through the walls. With plane detection, planes are now detected in all orientations. So not only vertical and horizontal planes, but slanted planes. And object tracking is some new APIs for ARKit. What you do is, with the help of CoreML, you train a model to recognize a 3D object, and then RealityKit will recognize that object, and you can attach different entities to it in 3D space. So in Apple's example, they're detecting this globe, and once the globe is detected, they launch a little rocket off of the Earth, and then there's also a moon that orbits the Earth. And they even went a step further and used an occlusion material on the detected mesh of that globe. So when the moon is rotating, it actually disappears as it goes behind the real-life 3D globe. And hand anchor prediction. So this is a big improvement to hand anchors and hand detection. If you're relying on really low latency and you're attaching something to the user's hands, but you want it to stay really close and accurate to where the hand movement is, you can actually get a prediction of where the hands will be in the near future. And you can attach the object to that position instead, and it leads to this really low latency hand prediction. All right, jumping into RealityKit 4. This is some of the stuff that I was the most excited about. First is custom hover effects, which is also available in SwiftUI outside of RealityKit. But in visionOS 1, all we really got was this little spotlight effect when we wanted to add an effect when someone looks at something. And Apple's big on privacy, so they don't let you execute any code when someone's looking at something. You can only use these kind of limited APIs around hover effects. And so now with visionOS 2, you can add a highlight effect. You can tint any entity any way you want. And then there's also some shader graph nodes that have been added so that you can do completely custom effects in your shaders when somebody is looking at an entity. And then in SwiftUI, similarly, you can apply any kind of transform to your SwiftUI views when someone is looking at it. You can create multiple animations. You can delay different animations and then group animations together. And it lets you create really great hover animations similar to the tab bar in visionOS, where it just shows the icons on the side, and then when you look at it, after a brief second, it opens up and it shows you the full label of each of those tabs. So things like that are completely available to us now in SwiftUI. Dynamic lights is a big one. So with visionOS 1, all we had for lighting was image-based lighting, which uses an HDRI image to apply that lighting to each of your meshes in the scene. And now we have dynamic lights. You can add directional, spotlight, and point lights. You can see in this example, the little spaceship has a spotlight on the front, and it's shining on the asteroids. And this is one example of the cross-platform support that Apple is bringing. They're bringing all the different platforms into parity. Dynamic lights were previously available in RealityKit on iOS, but they weren't on visionOS. So now those are being brought to visionOS, and other APIs that were in visionOS, like a reality view, the shader graph, or spatial audio, those are coming to iOS and macOS. So this makes it really easy if you want to port your visionOS RealityKit app to some of these other platforms, or just combine all of your RealityKit code to be more cross-platform. There are some portal enhancements. So a portal is where you have an immersive scene and it's masked through a mesh. With visionOS 1, those objects were completely masked, so they only existed within the portal. And with visionOS 2, they've added the ability to cross out of the portal. So you can have things that are masked inside the portal and then they gradually come out into your real-world space. Reality Composer Pro timelines. So these let you author timelines and animations within Reality Composer Pro. You can animate entities that are within your scene. You can spin or translate different things, and you can also perform actions on this timeline. So you can do things like play an audio, or you can post a notification that you actually respond to within your code. And the RealityKit debugger is super helpful if you're working in RealityKit. So just like we have in UIKit and SwiftUI, we have the view debugger. Now in Xcode, you can debug your RealityKit scene. So you can hit pause, and you can see your RealityKit scene in 3D, and you can actually go through the entity hierarchy and inspect all of those entities, as well as all their components and the properties of those components. And then we have some other things that might be familiar if you're working with other game engines like Unity. So we have force effects and joints. With force effects, you can apply continual forces to physics bodies within a volume. So you could use a vortex force that circulates the entities around an object, or you could have a drag force that slows things down as they enter the volume. With joints, you can create physical constraints between entities. So now you could, for instance, attach a trailer to a car, and then that car would actually pull the trailer around. Inverse kinematics. So RealityKit now has a full body IK solver that can be used with skeletal meshes so that you can position joints and then have the intermediate joints positioned appropriately. So a good example of this is if you want to position a hand somewhere, the elbow follows it in the right place. With blend shapes, you can smoothly transition between different poses. So in this example, this little flower transitions between its pose where it's completely wilted up to where it's completely healthy. And blend shapes are commonly used when you're animating characters' faces, for example. Skeletal poses, so you can actually manipulate the transforms of joints in a skeletal mesh, similar to what you would do with inverse kinematics. The billboard component, this makes it really easy for any of your entities to always face the user, so you don't have to worry about grabbing the camera transform and manipulating the rotation of all your objects. You can just apply this billboard component, and that will always face towards your user, no matter where they are. And there are also some low-level mesh and texture APIs if you want really fine-grained control over creating and updating custom meshes, as well as texture resources. So enterprise APIs. So the first thing about enterprise APIs is these require additional entitlements from Apple. You must request the entitlements through Apple to have them added to your app, and these apps must be distributed privately. So either through in-house distribution with an enterprise Apple account, or through the Apple Business Manager, where you can privately distribute apps through the App Store. And so these aren't actually available in public App Store apps at all. The first one is main camera access. So you can get full access to the camera's video feed, and this could be used, for example, on a production line using a computer vision algorithm to detect anomalies. There's also pass-through in screen capture. So when you're using the screen capture APIs, currently when you do that, you can see all the windows, but the pass-through video is just completely blacked out. And so with this enterprise entitlement, you can now use screen capture and capture everything that the user is seeing. And so this could be used when you're trying to remotely troubleshoot something. You can send exactly what that person is seeing through the screen capture. With spatial barcode and QR code scanning, you can get the location and the payload of different barcodes. So this could be used in a warehouse where a worker wants to just look at a package barcode and immediately see what's inside of it. With Neural Engine access, if you want to run ML tasks and actually take advantage of Apple's Neural Engine, you can do that with this extra entitlement instead of being able to run just on the CPU and GPU. And enhanced object tracking. I talked about the object tracking APIs in ARKit earlier. With the extra enterprise entitlement, you can detect more things, more objects being tracked. You can increase the tracking rate or the detection rate of the object tracking. And there's increased performance headroom. So you can opt into this and use more of the CPU and the GPU resources at the trade-off of having the fans run a little bit harder. So this is one that I was really excited about, some immersive environment authoring improvements. So this is when you're designing a fully immersive environment, specifically around playing some media. So right now there's, in visionOS 2, video player docking. With visionOS 1, when you use the full screen AV player view controller, it just sat in a static place right in front of the viewer. With visionOS 2, you can now dock this to any place within your scene where it might be appropriate. So if you have a movie theater, you could throw it up right on the movie screen instead of having it just floating right in front of you. And video reflections, you can see in this example how the video has these really nice reflections that are on the floor. This is something that Apple has supported now so that you can add both diffuse and specular reflections to your environment and just make that video feel even more immersive when you're watching it. Hand brightness and tint. So I'm not sure if you've been in an immersive scene in the Vision Pro where it might be pretty dark, but your real-life environment is very well lit. If you look down at your hands, they're super bright, and it takes you out of the immersion completely. So with visionOS 2, you can now control the hand brightness and the tint. So if your immersive scene is really dark, you can just tint the hands to be pretty dark as well. With reverb, you can now add reverberation settings to your immersive scene so that the audio in that scene reflects the geometry of your immersive scene and not the user's real-life environment. And SharePlay. So SharePlay has added support for syncing these immersive environments between users when they're watching a movie together. And let's see, some other updates. So Tabletop Kit. So Tabletop Kit is a new framework that is tailored to tabletop games, and it handles a lot of the things like the player seating, the entity setup of the game pieces, some of the gestures and interactions with those game pieces. And it all comes with SharePlay integrated, so multiplayer support is there. And it lets you really just focus on the game mechanics of your game without having to worry about how to get people seated in different positions around the board and things like that. With HealthKit, so the same HealthKit APIs that are available on other platforms have been brought to visionOS. So whether you're making a visualization that reads HealthKit data, or if you're building an immersive workout app that needs to write data to HealthKit, all these APIs are available to us now. With multi-view video, this is a way that you can have multiple AV player view controllers at a time, and it lets the user select as many videos as they want. You can see in this example watching some soccer games, and then having a few of them on the side, and then this framework in AV Foundation takes care of making one video the primary video and controlling playback of all of these through a single control bar. Custom spatial persona templates. So with visionOS 1, if you're integrating SharePlay in your app and you're using spatial personas, you have just 3 spatial persona templates. And that's how the different spatial personas are aligned in relation to each other. So you could have side-by-side, conversational, where they're kind of in an arc, or circular, where everyone's sitting around a central area. And with visionOS 2, you can now make your own custom spatial persona templates. A good example would be a chess game. Maybe you have 2 people sitting at a table, playing the game, and then everyone else is a spectator located around the table itself. And something that I was very excited about, I'm not sure if you've tried to develop SharePlay for your visionOS app, but you either have to have an iOS app that you're SharePlaying with yourself, because you can't put on, even if you had 2 Vision Pros, you can't put on 2 Vision Pros at a time. So you'd either have to use an iOS app or have some of your coworkers with Vision Pro, and you keep having to bug them to test. So with visionOS 2, the simulator actually supports simulated FaceTime calls. So you can develop SharePlay apps really easily within the simulator. Awesome, and that's all the updates. Thanks, everyone. Here's my... Here's my contact info, and feel free to reach out to me at the conference anytime, and if you want to talk about visionOS 2 and all these fun new updates.